Hello all, this is Mr. G and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, come back when you think you have an answer. Three, two, one, let's go with the answer. There's actually two different ways to attack this problem. We see we have a quadratic equation, 3x squared plus 9 equals 12x. Remember, we know it's a quadratic because we have that power of 2 with the x. Our two main strategies for this, well, I guess we could try and get x by itself. That's not going to work. We see, unlike terms, we see an x squared and an x to the power of 1. So really we have two strategies at this point. We can either try and factor it, or we can use the quadratic formula. And I'm going to show you both ways, so that way you can sort of check your work depending on what strategy you use. But you should get the same answer no matter which method you use. Remember, factoring the quadratic formula, they're not like two completely separate different topics. They're two different strategies for solving the same type of equation. All right, that's enough talking. Let's get into this. First thing we need to do is take away 12x from both sides. That's going to be true whether we are factoring or using the quadratic formula. So we get 3x squared minus 12x plus 9 equals 0. I'm going to show you how to factor this first because that's always what I try and do first. I always look to see if I can factor it. First thing we need to do for factoring is divide out a GCF, and there's a GCF of 3. So we can put this 3 in front, 3 times x squared minus 4x plus 3 equals 0. At this point, some students get confused, like, wait a minute, what do we do with this 3 in front? Well, I mean, it's 3 times all of this, so to undo multiplying by 3, we can just divide by 3. That'll cancel out the 3, we're just left with a trinomial, a quadratic trinomial. X squared minus 4x plus 3 equals, and 0 divided by 3 is still 0. So dividing out a GCF makes the numbers a lot easier to work with. We don't need the stupid sentence here anymore because we have a lead coefficient of 1. Let me see. We want two numbers that multiply to get positive 3 and combine to get a negative 4. That's going to be a negative 3 and a negative 1. Now we just use the 0 product property. X minus 3 equals 0. X minus 1 equals 0. And then hopefully you can skip this step. I'm going to show all my work though. Add 3 to both sides. X equals 3. Add 1 to both sides. X equals 1. So x equals 3 and x equals 1. That's how you can do it solving by factoring. Well, what if you solved it with the quadratic formula? Let's go through that. So it's 3x squared minus 12x plus 9, just subtracting 12x from both sides, just like we did in the factoring method. Now, even if we're using the quadratic formula, we could still divide out the GCF of 3 here to make the numbers a little easier to deal with. But I'm going to leave it as it is, because that's what most students do, in my opinion, or in my experience, I should say. So A equals 3, B equals negative 12, and C equals 9. Let's see what we get from the quadratic formula. Remember, it's negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And now let's substitute and do a little simplifying to make this a little quicker. So let's see, negative b is minus a negative 12, that's positive 12, plus or minus the square root. B squared is negative 12 squared, that's positive 144. Let me see, minus 4ac is going to be minus 4 times 3 is 12, and 12 times 9 is 90, and 18, that's 108. All divided by the square, not the square root, all divided by 2a. That's 2 times 3, that's 6. Misspoke there, but that's all right. Let's see, what can we do now? It becomes 12 plus or minus the square root of, well, 144 minus 108, that's 36, if I'm not mistaken, or the square root of 36, divided by 6, and then we just get 12 plus or minus the square root of 36 is 6, divided by 6. Now, we've got two options here. We could distribute the division and write it as 12 divided by 6 plus or minus 6 divided by 6. That's one way we could do it. Or you could deal with the plus or minus first. I'm going to deal with the plus or minus first, but either way, you'll get the same answer. So one way would be 12 plus 6 divided by 6. That's 18 over 6. That's 3. So that's one answer. And if we subtract, we get 12 minus 6 over 6. That's 6 over 6, and we get 1. We get the same exact two answers that we did solving by factoring. So the reason I wanted to show you both of these methods is to really ingrain in you that factoring and the quadratic formula are two different ways to get to the same answer, as long as your quadratic is factorable. If it's not factorable, then the quadratic formula right now is your only option. But that's going to change in today's lesson, because today we're doing chapter 4, section 6. After today, we should be able to solve quadratic equations by completing the square. Now, completing the square, I'm going to be perfectly honest. This is not one of my preferred methods for solving quadratic equations, but some students end up liking it, and I just want to show you how to do it in this video. So let's jump right into example 1. It says solve the equation x plus 5 squared equals 144. I'm going to rewrite that down here so I have a little bit more space. Now, I've got a question for you. Is this a quadratic equation? Is this a quadratic? Now, hopefully you're saying yes, because this is a quadratic, even though it looks a little bit different. We've got a binomial here that's squared. But remember, since we're squaring this, we're still going to end up with an x squared if we simplify this. So this is still a quadratic equation. Now, some of you might be thinking, oh, okay, Mr. G said simplify, so let's jump in and start simplifying. Let's do x plus 5 times x plus 5. Let's distribute or FOIL, depending on which method you prefer. But we don't need to do any of that. There's a much faster way to do this, because this whole binomial, that whole side of the equation is raised to the second power. So we can just undo that power of 2 with a square root. We can take the square root of both sides. Now remember, the square root and a power of 2 are inverse operations. They undo one another. So all that's left on the left side is x plus 5 equals, the square root of 144 is, did you just write down 12? If you did, that's a little mistake. It's positive and negative 12. Remember, whenever we take the square root of both sides of an equation, we have to worry about the positive and the negative possibility, because positive 12 times positive 12 gets us back to 144, and negative 12 times negative 12 also gets us back to 144. Let's see. Well, then we would just subtract 5 from both sides, and we would get x equals, let's see, if it's positive 12 minus 5, that would be 7. And x equals, if it's negative 12 minus 5, that would be negative 17. So those are our two answers, x equals 7 and x equals negative 17. I want you to try example, why did I say example 1 twice? Oh well, I want you to try example 2 on your own. I wonder if the rest of my numbers are mixed up, but we'll fix them when we get there. All right, let's try this one on your own. Solve the equation x minus 2 squared equals 11. We're going over the answer in 3, 2, 1, let's go. So first thing, x minus 2 squared equals 11. We see that power of 2 we need to undo. We can undo it with a square root. They go away. We end up with x minus 2 equals, now we can't simplify the square root of 11 any further. There's no perfect square factors, and 11 is not a perfect square. So I'm just going to write this as plus or minus the square root of 11. I mean, that's a perfectly fine number. We don't know exactly what it is, but it's the square root of 11, positive and negative. Let's see. Then we would add 2 to both sides, and we would get x equals 2 plus or minus the square root of 11. Now, this is how we can leave it in an exact answer. But if you wanted to use a calculator to get a decimal approximation, let's practice that as well. So in my calculator, I'm going to hit 2 plus second square root 11, and I got 5.32 it rounds to. And then if we subtract it, so that would be 2 minus the second square root of 11, that's negative 1.316, so it rounds to 32. So there's our answer as an exact number and as a decimal approximation. You need to be able to write them both ways, as an exact answer and as a decimal approximation. Now, I wouldn't blame anyone for being kind of a little, maybe not confused, but sort of suspicious at this point. It's like, wait a minute, I thought we were talking about like completing the square. Mr. G hasn't said anything about completing the square yet. He just showed us 2 examples where we can take the square root first. The reason I started with 2 examples like this is because when we're completing the square, we're going to end up with an equation that looks like that about halfway through. So now, once we talk about the completing the square method, once we get about halfway through and we see an equation like that, you're like, oh yeah, we just did example 1 and 2. We just applied that same strategy. So let's jump to completing the square. Now, completing the square is sort of a weird thing to teach in person in my experience, so it's even a little weird to teach through this video, but I'm going to do the best I can. We'll see how this goes. So let's start with the basic question. How can we create a square? Now, when I say that, I don't mean how can we make like a square like a shape. I mean, how can we create a square number, a perfect square? Well, to create a perfect square, we can just take any number we want and square it. So say we have 3. That's not a perfect square, but if we square it, it gives us a perfect square of 9. Same thing if we had an 11. That's not a perfect square, but if we square it, it gives us 121. That's a perfect square. What we're going to do is we're going to apply this strategy to trinomials, perfect square trinomials. And the way we create perfect square trinomials is by squaring a binomial. So admittedly, this is going to look a little bit different than what we did on this last slide, but it's the same exact idea. Okay, we have a number, we square it, it gets us to a perfect square number. Okay, here we've got a polynomial, x plus 7 squared. When we square this, it's going to get us to a perfect square polynomial because we're squaring something. That's just how squaring works. So let's see what happens. I'm going to leave my final answer right there, so I'm going to do my work below it. I'm going to scroll down a little bit. So x plus 7 squared, to simplify this, it's x plus 7 times x plus 7. There are shortcuts to get around this. I'm just showing all my work at this point. It's x plus 7 times x plus 7. Remember, that's what a power of 2 means. We take something and we multiply it by itself. Then we could FOIL. I prefer distributing here, so x times x is x squared. X times 7 is 7x. And 7 times x is 7x again. And 7 times 7 is plus 49. And then we end up with x squared plus 14x plus 49. So that's what we get here. X squared plus 14x plus 49. So what we have right here is a perfect square trinomial. It's a perfect square trinomial because it equals, of course, all this here, because it equals a binomial times itself. I want you to try and simplify this one on your own. Pause the video right here, simplify x minus 4 squared, and once you're done, look for some patterns. Look for like patterns in the numbers we had here and there, and look for patterns between the numbers you got there and the numbers you got there. All right, once you have your answer. So 3, 2, 1, let's go over it together. So x minus 4 squared, that's x minus 4 times x minus 4. Then we distribute x times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is plus 16. Okay, then that becomes x squared, combine our like terms. We get negative 8x plus 16. We end up with x squared minus 8x plus 16. Now let's talk about some patterns we notice here. Specifically, the numbers we ended up with and the number we started with. So we got a 49, a 14, and a 7. And down here, we got a 16, a negative 8, and a negative 4. What patterns do you notice here? There's 2 main things you need to notice. This 49 and this 16 are the how do I want to say this? They're the square of the number we started with. We square 7, we get 49. We square negative 4, we get 16. So the C term is a perfect square based on the number we had in our binomial. What about the number in the middle? The 14 and the negative 8. Hopefully you're noticing that it's just double the number we started with. If we double 7, we get to 14. If we double negative 8, if we double negative 4, we get to negative 8. It's really important to see those patterns because what we're really doing when we're completing the square, we're essentially going to be given something that's not a complete perfect square. We're going to be given like the first pieces of it, and it's going to be up to sort of create, that's not what I wanted to move. It's going to be up to us to find the missing constant, the missing C term that would complete the square. So let's practice that right now. I know that probably sounds a little weird, but let's take a look. Hopefully it'll make more sense after this slide. So we've got x squared plus 16x, and we have to complete each square. So what we have here is not a perfect square trinomial, but we want to make it a perfect square trinomial by completing the square. So let's think about this. I'm going to put a little thought bubble right here. This is what I'm thinking. Well, if it's going to be a perfect square trinomial, that means it needed to come from a binomial squared. So x plus something or x minus something squared. So what number would go there for x squared plus 16x? The answer is a plus 8. Plus 8. And if you're not sure where that came from, remember, let's look back here. This key number right here, that's 7. That's really what we're looking for figuring out, okay, what's going to go in our binomial was half of 14. And we saw the same thing down here. This -4 was half of the -8. So, okay, we see this 16x. If we take half of it, that will be the number we want in our binomial. So to complete this square, what number is going to have to go right there? Well, let's think back. Okay, so let's look back at our last slide one more time to make sure we're seeing this pattern. This last number, the 49, I keep moving the wrong one, the 49 and the 16 were whatever we had in our binomial multiplied by itself, squared. So -4 squared, positive 16. Positive 7 squared got us to positive 49. So what number goes right here? Well, it's just going to be the positive 8 squared, and that's going to be 64. Whenever you're completing the square, this is the way I like to do it at least, it's all about, even if you don't write this down, just thinking, okay, what binomial would create the perfect square trinomial I'm looking for? All right, let's keep on practicing this. So we got x squared plus 20x. We have to figure out how to complete that square, what the constant, what the c term is going to be to create that or turn that into a perfect square trinomial. Again, we've got a thought bubble over here with, all right, let's think of our binomial. What do we want to square to create our eventual perfect square trinomial? Well, we got the b term, and remember, in the binomial, we always have half of that. So if it's a 20, it's going to be a plus 10 because we just take whatever's in front of the x to the power 1, and we take half of it. So x plus 10 is the binomial that would create this. So the c term is going to be 10 squared, 100. Let's take a look at another one. So x squared minus 8x. Again, we think of our thought bubble here. What's going to be the binomial squared? It's going to be x. Let's see, we see a minus 8x, so we have to take half of that. It's going to be x minus 4 squared. So then back here, well, it's going to be -4 squared. That's not going to be a -16. That's still a positive 16. Because negative times negative becomes positive. All right, I want you to try this last one on your own. X squared minus 2x, complete the square. We're going over 3, 2, 1, let's go. The binomial we want is x minus 1 squared, because -1 is half of -2. That means to complete the square, -1 times itself would be a positive 1. So plus 1 would complete that square. Right, hopefully you got that correct. And now we're finally ready for our first actual example here. Everything we've done up to this point has been set up. So we got to solve the equation x squared plus 8x equals 1. So x squared plus 8x equals 1. Now keep in mind, this is still a quadratic equation, so you could try to factor it, you could try and use the quadratic formula, and those methods will still work perfectly well. I mean, I don't know if everything we're going to see today is going to be factorable, but the quadratic formula would work for every single one of the examples. So after this lesson, if you're like, man, I just don't like completing the square, great, whatever. Just use the quadratic formula and you'll still get the same answer. Now, when we're completing the square, this is, how do I want to say this? The first step in completing the square is very different from factoring of the quadratic formula. If we were going to use factoring of the quadratic formula, we would want to subtract 1 on both sides. But in completing the square, we don't want to do that. When we're completing the square, we want to have on one side of the equation something that looks like that. A binomial, sort of an x squared plus an x term that we can complete the square for. So basically, we want to be looking at something like this, or this, or this, or this in our equation if we're completing the square. And if we look at example 3, we already have that. We already have x squared plus 8x. So we can rewrite this as a binomial square. So this is sort of what was in our thought bubble on the last slide. Okay, what is our binomial going to be if we had an x squared plus 8x? Oh, and this is important. I skipped a line here. So if you're following along, make sure you do that in your notes as well. So let me see. Well, it's just going to be a plus 4. X plus 4, because we take half of 8. Just take half of 8. But the problem is, x plus 4 squared does not equal x squared plus 8x. It equals x squared plus 8x plus 16. We completed this square. So we're actually adding in a 16. By adding 16 on the left side, we get a perfect square trinomial that we can rewrite as a binomial square. That's the key step to completing the square, finding this number and then squaring it to create our perfect square trinomial. But remember, this is an equation. We can't just add numbers in willy-nilly. We have to be really careful about what we're doing here. We went from an x squared plus 8x to an x squared plus 8x plus 16. We added a 16 on one side of our equation. Well, let's think back to the very first thing we learned about equations way back in, I don't know, 7th, 6th, 8th grade, depending on what math teacher you had. Anything you do to the left side, you have to do to the right side as well. So if I added 16 on one side, I have to add 16 on the other. All we did here, so okay, x squared plus 8x, we do plus 16 on the left and plus 16 on the right. That's all we did there. So then we can rewrite the right side as 17. Now, eventually you might get good enough where you can skip this step entirely and just go straight to that step, but I'm going to show my work for the rest of these because I don't want to lose anyone. Now, hopefully this looks really, really familiar. It's like, oh, wait a minute. This is exactly the type of example we saw in example 1 and example 2. We know how to deal with this. To get rid of the power of 2, we take the square root. To undo it using inverse operations. Then we get x plus 4 equals, that square root of 17 is not going to be, or cannot be simplified. I'm just going to leave it as plus or minus the square root of 17. And then we just have to take away 4 on both sides. We end up with x equals negative 4 plus or minus the square root of 17, and we are finished. That's the exact answer. I guess we could find a decimal approximation. We do that real quick. So in a calculator, I'm just going to do, turn this back on, clear it, negative 4 plus the square root of 17. That came out to 0.12 it rounds to. And if we subtract it, that would be approximately negative 4 minus second square root 17. That came out to negative 8.12. So we have an exact answer and 2 decimal approximations. Again, it's really important that you're able to find both versions of this answer. Let's do another one together. One more together, then one on your own, and that'll be the end of the lesson. So we're going to solve the equation x squared minus 10x plus 22. I'm going to rewrite that here just to get a little bit more space for my work. Now, if we're going to solve this with completing the square, then we need this x squared minus 10x by itself. So let's take away 22 on both sides. So we end up with x squared minus 10x equals negative 22. And now we're ready to complete the square. We've got a binomial here just waiting to be rewritten as a perfect square trinomial. So I'm going to skip a space and go straight to my binomial. Now, other teachers, when they teach completing the square, they don't skip that step. They don't go to the binomial first. But I think it's really worthwhile. It's really the only way that completing the square makes sense to me is to go, okay, what's my binomial? What's the key number controlling everything going to be? And that's going to be a minus 5. That's going to be what we end up with once we factor our completed square. But x minus 5 squared doesn't equal x squared minus 10x. It equals x squared minus 10x. But then there's the third term, the completed, or the third term that completes the square there. So let's see, that's negative 5 squared. That would be plus 25. So we added 25 on the left side. So we add 25 on the right side, and we end up with a positive 3. Now we just take the square root and move on. Undo that power of 2. We get x minus 5 equals plus or minus the square root of 3. Remember, anytime we take the square root of both sides, we need a positive and negative possibility. Then we add 5 to both sides. Scroll down a little bit. Get x equals 5. That should be a plus. 5 plus or minus the square root of 3. That's our exact answer. Let's get some decimal approximations just to practice that as well. 5 plus second square root 3. We get 6.73 rounds to. And x is approximately, if we subtract 5 minus second square root 3, I got 3.0267. So that would be 3.27 would round to. 3.27. So we got a exact answer and 2 decimal approximations. All right, last one. And I want you to try this one on your own. There's one little trick to it at the start, but I think you can handle it. So pause the video right here. We're going to go over the answers in 3, 2, 1. Let's go. We got x squared plus x equals 3x plus 7. Let's see. We need to get the x squared and the x terms together. So let's subtract 3x on both sides. And we end up with x squared minus 2x equals 7. Now we're ready to complete the square. Let's skip a step, skip a line, and go to our binomial. It's going to be x something squared. It's going to be negative 1 because it has to be half of our b term, half of that negative 2. Or I guess a better way to say it is half of the, just half of b, half of b. So let's see. X minus 1 squared actually equals x squared minus 2x plus 1. So we add 1 on the left side, so we're adding 1 on the right side. So that becomes an 8. Then we take the square root of both sides, cancel that out, and we end up with x minus 1 equals, I'm not going to write plus or minus the square root of 8 because we can simplify the square root of 8. Let's do this over here. So there's another little thought bubble. We can rewrite the square root of 8 as the square root of 4 times 2. And normally we don't need to do this with a number. Like we didn't do this in any other step. The only reason we're doing it now is because 8 has a perfect square factor. We can take the square root of 4. The square root of 4 is just a 2, and the other 2 just stays inside the square root. So this is what I'm going to write instead of the square root of 8. Plus or minus 2 times the square root of 2. Then we add 1 on both sides and get x equals 1 plus or minus 2 times the square root of 2. Now some students might be watching this and think, well, wait a minute, why didn't we combine the 1 and the 2? The reason we didn't do that is because it's not just a 2. It's a 2 times the square root of 2. So they're not like terms. You can sort of think it that way. They're not like radicans. But if you don't know what that word radicans means, we'll go over that in a separate video. So don't worry about that right now. Just know that we cannot combine the 1 and the 2. Let's get a decimal approximation though. So it's 1 plus 2 second square root 2. That comes out to 3.83. Rounds to 3.83, I should say. And then if we subtract 1 minus 2 second square root 2, we get negative 1.83. And there we go. Hopefully that's what you got. Here's our homework. It's page 237 in your textbook, numbers 37 through 39. One little warning for these problems. If you're going to complete the square, they're a lot easier if you have a lead coefficient of 1. If you have a lead coefficient that's not 1, completing the square becomes a lot more difficult, and I honestly wouldn't even bother with it. So only try this method if you have a lead coefficient of 1. All right, this video is long enough. Enjoy the rest of your day. I will see you tomorrow.